I'll just upload this in Animo space. Okay. So again, the purpose of this tutorial is, well, the presumption of this session is that you have at least tried answering the questions displayed in the. So naka-display naman siya. Yeah, yung problems or the exercise set as displayed in your screen. So I of course I believe there's some problems here that are quite easy to solve, I think. And there are certain problems that you may find challenging. So can you just tell me which numbers do you think are a little complicated? And then we'll try to solve that today. Okay. Kanina, yung mga na-solve na is yung numbers, number 9. We started with number 9. We also solved number 10, number 11, and number 13. Right? So kung if you find those numbers difficult as well or medyo challenging, we can use the same items for discussion. So, ano yung numbers na pwede nating i-solve?
Sir, number 9 po sana, hindi po kasi ako makapag-push through dun sa isa pong equation eh.
Okay. So, let's start with number...
Ayun po, 9 to 13 po.
Ayun, yung same,
this
no?
what
9...
like fresh, yes po.
Oh, 9 to 13. Okay.
Yes,
sige.
Sige.
Let's start with equation 9. Sorry, with problem 9. So, again, tama-tama, at least recorded na tong session na to. Makikita din nung yung earlier group. Okay. So, equation 9, the problem is you wanted to show that A is idempotent. So, suppose X is an m by n matrix, and we just assume that the determinant of x prime x is not equal to 0. So in other words, x prime of x is non-singular. So we just wanted to prove that matrix A, okay, let me just share another screen. No, matrix A, let me rearrange some of the items here. Okay, so matrix A is equal to, or at least what's given, is equal to IM, where IM refers to an identity matrix. So if you check your notes, an identity matrix is basically a special kind of matrix such that when you multiply any matrix that has the same dimensions as matching dimensions with the identity matrix, you will get the same matrix itself. In college algebra, that is tantamount to the number 1. Your identity matrix, it's like number 1. Now, when you try to multiply any number with 1, you'll get the same number itself. In the world of matrices, the identity matrix acts or behaves like so. No? So when you multiply any matrix with the identity matrix, you will get the same matrix. Right? So X, so here we have A, it's equal to the identity matrix minus X times X transpose X inverse X transpose. Now, we just wanted to show that A squared, or in other words, A times A is equal to A itself. So that's the definition of an idempotent matrix. So ano gagawin natin dito? We'll just multiply. We'll just execute this multiplication. So what happens is that A squared is basically equal to this expression IM times itself, right? Okay, so at first glance, it may look like it may look like you can solve this using the FOIL method. To some extent, it's true, but there are certain operations in algebra that you cannot use in matrix multiplication. So what I'm going to do here is I'm still going to distribute. Right, I'm still going to distribute one of the binomials across the other. binomial. So let's say I'm going to distribute this second term. I'm going to distribute the second term here, right, across these two terms. So this will be equal to I m, sorry, I small m times I small m minus x, sorry, x transpose x inverse x transpose, okay, minus minus this term, minus this second term, second binomial, times, okay, the second binomial times, sorry, the second term rather, the second term times the second binomial, which is this. Okay, copy this, paste it here. Okay. So now it's just a matter of distributing the remaining terms. Now, for the first term, since this is a matrix, all right, this bracket, this term in the parentheses is a matrix. Now, when you multiply this matrix with an identity matrix, you will still get the same. You're supposed to get the same matrix. Hence the identity property. Hence the definition of an identity matrix. Now, when you try to multiply this matrix with an identity, you're supposed to get the same. You're supposed to get the same um, matrix. Okay. So copy mo lang siya dito. Or in other words, you can just cancel the identity matrix out. Okay. Now, let's distribute this second term across the binomial. So this is going to be equal to x transpose x inverse x transpose I, sorry, I m I small m plus, right, plus x transpose x inverse x transpose x. X times x transpose x inverse x transpose times itself. No? I-multiply mo to, i-multiply mo tong term na to dito. Right? So I'm just gonna copy it here. Okay. Now let me just copy this entire expression. The next slide. Okay. Now, ano pa yung pwede nating i-simplify, right? Notice here that I multiply this matrix with the identity. So the identity matrix will just cancel out, okay? So this binomial term remains as is, okay? And this term also remains, okay? This one. Okay. Copy this. Now, punta tayo dito sa third term. Yeah, punta tayo dito sa third term. Recalling, or I already posted that in the slides, no? The property of inverse matrices. X transpose X inverse multiplied by X transpose X, anong mangyayari dito? What exactly happens here, right? If I multiply X transpose X with its inverse, what do you get? You'll be getting an identity matrix. It's in algebra, it's analogous to multiplying a variable X with its inverse, right? Ano ba yung inverse ng X? That's 1 over X, right? So analogous yun. Right? Analogous, not exactly the same procedure, but the principle is analogous. Meaning, if I multiply X with its inverse, or if I multiply X with 1 over X, ano mangyayari? Ano mangyayari sa expression? Uy, basic algebra lang yan. Ano mangyayari dun sa expression if I multiply
1, sir.
magiging 1, di ba? So in a similar note, if I multiply a matrix with its inverse, I'll be getting an identity matrix. So in essence, it's like canceling it's in essence, it's like canceling the matrix out or transforming it to 1. No? So magiging identity matrix to, right? This essentially cancels out, and then you're left with what?
Yung same po, X,
You're
X,
left with yeah, correct.
yung
You're
pong
left with
nauna po, kanina na term.
correct. So you're left with x times x transpose x inverse x transpose, correct? Kasi nga ito naging identity matrix. So kumbaga nawala yung nakasandwich na matrix dito. Okay? So you're left with the similar term. Now, ano pa yung pwedeng ma-cancel out? Right? Ano pa yung pwedeng ma-cancel out? This is the
Yung dalawa
negative
po.
of x transpose. Yeah, okay. So this negative, you add it with a positive matrix like this one, or with this one, right? Magiging 0 to, diba? This will cancel out, and therefore you're left with the original expression of A. Okay? So therefore we have proven that A we have proven that A squared is equal to I've proven that A squared is equal to A. We have shown that A squared is equal to A. Okay, okay. Questions?
Sir, bali okay lang naman po if naglet po ako ng variable para po dun sa ano po, no? Ginawa ko po kasing alpha or mas preferred niyo po na naka-ganito po?
If it were the same college algebra computation, that's fine. Pero since matrices kasi itong involved, you cannot just set a matrix
Okay
equal
po.
to some variable. May nuances kasi yung matrix operation na kapag pag halimbawa binaon mo siya pinlog in mo siya in a certain in an arbitrary variable, nag-iiba kasi siya. Right? It's gonna be different and you may end up getting the wrong answer. Oo.
Na kaya po natigil po ako dun sa Okay, I see po. Alam ko na po. Thank you po, sir.
Matrices to matrices ang ang equivalence
kumbaga. As is po ang gagawin
po.
Sige po.
And take note na there are certain properties in algebra that may not be applicable to matrices. For instance, ang crucial dito yung commutative property of multiplication. Sa college algebra, we can switch variables, right? We can switch the position of variables. XY is equivalent to YX. But as you have seen in the exercise, you were able to show na if I switch the position of say two matrices A and C, it's not the same as C and A. Diba? Yung product ng dalawang matrix AC, it's different from the product of C and A. Of course, under special circumstances, it could be the same. But generally speaking, they're not similar. So, matrix multiplication is not commutative. Okay, so that's number 9. Number 10, magkakasunod nga to. 9, 10, 11, 13. Right? I think that's sufficient enough. The rest are quite mechanical naman. So let's try to solve again. Let's try to solve number 10. Okay. Unless of course you have other questions, we can just address that later. Okay, so let's solve number 10. So number 10, we defined a 3x3 matrix. Okay. This is also a little bit. This is also mechanical. You just have to again review a bit of your college algebra in order to find out for which values of P and Q does A plus E have an inverse. So let me just copy this. So you have Q. So you have Q negative 1. You have Q minus 2. You have 1, you have negative P, you have 2 minus P, you have 2, you have negative 1, and then you have 0. Okay. Okay. So that's your matrix A. And you have another matrix denoted as E. Okay. Okay, and again, just a reminder, please do not confuse E with identity matrix. Hindi ibig sabihin na puro 1 yung elements nito, identity matrix na siya. Hindi. An identity matrix is a matrix whose diagonals are equal to 1 and the off-diagonal elements are 0. So, ngayon, pag multiply mo itong E with another matrix, you'll not get the same matrix kasi nga hindi naman identity to. The only time that E will be an identity matrix is if the off-diagonal elements are equal to 0. Okay? So as it is, E is not an identity matrix. So don't be confused. Okay, so let's get the determinant of A. Again, as I mentioned in the tutorial videos, in getting the determinants, choose the row that has the most number of zeros. So in this case, you have row 3. Okay, you have row 3. So let's get the determinant. So to get the determinant, you multiply the first element, the first element in row 3, which is 2, and then you multiply it with the resulting matrix, resulting submatrix obtained by deleting the rows and columns where 2 is located, right? So since 2 is in third row, first column, you delete the third row and the first column. So you get the determinant of a 2 by 2 matrix that contains negative 1, q minus 2, negative p, and 2 minus p. Okay? Next element, negative 1. Now, take note that ano ba yung index? What's the index of negative 1? Where is it located? It's located at the third row. It's located at the third row, second column. Now, if you add the indices, ano yung index? That would be the row number and the column number. If you add the row number and the column number of negative 1, anong kalalabasan? Row 3, column 2, so that's 3 plus 2, that's 5. So if the sum of the indices is an odd number, then it must be multiplied by negative 1. So this will be negative minus 1, which is yung element sa third row, times the determinant of the resulting submatrix obtained by deleting the third row and the second column. So if I delete this and this, if I delete this third row and the second column, I'll get q minus 2, I'll get 1, and I'll get 2 minus p. Okay. Now, how about 0? Since this is already 0, you can just disregard that kasi nga 0 naman to. Anything that you multiply with 0 is 0. So that kind of makes your job a little easier kasi you just need to solve for these two expressions. Now, expanding this, okay, so the determinant of A would be equal to 2 times, what's this? This is negative 2 minus p. So negative 1 times 2 minus p, that's negative 2 minus p. Minus p, minus negative p times q2. So since it's negative on negative, this will just be plus p q minus 2. Okay. And here you also have a negative on negative, right? So this will just become positive of what? The determinant of this 2 by 2 matrix. So what's the determinant of this 2 by 2 matrix? This is q times 2 minus p minus what? 1 times q minus 2. So that's q minus 2. Okay. Now, expanding this expression, you have the determinant of A that will be equal to negative 2, 2 minus p, sorry, 2 minus p, plus 2p, okay, 2p, q minus 2 plus q, 2 minus p, and minus q minus 2. Now, we can group some of the similar terms together now for easier computation. So let me just copy that. Let me just copy this in the new slide. Let's copy this here. Okay. Let me group some of the terms together. So the determinant of A would be equal to negative 2 minus P plus Q 2 minus P, okay, plus 2P Q minus 2 minus Q minus 2. Okay. Okay, so negative 2, okay, negative 2, 2 minus P plus Q, 2 minus P plus 2P, Q minus 2 minus Q minus 2. So regrouping terms together, right, we can factor out something, no? So this becomes the determinant of A. This becomes Q minus 2, right? 2 minus P, right? Bakit? You distribute this and you'll get the same expression, the first two expressions here. Plus, uh, 2p, 2p minus 1, q minus 2, correct? So I factor out q minus 2, I'll get this 2p minus 1. And I can factor out this a little further. So you have the determinant of A, and that's going to be equal to q minus 2.
Minus 2 and P
Yeah, so this is going to
plus
be
1
2 minus P, sorry, 2 minus
minus
P
P.
plus 2P minus 1. And I can
1.
group terms now, right? You can
Yes
group
po.
terms together. And therefore, the determinant of A, it's a little mechanical, but tiyaga lang kailangan. So, adding similar terms together, the determinant of A would be Q minus 2
It's 2
times,
P
what's
plus
this?
1.
That's gonna be P. Diba? Kasi negative P plus 2P, that's
2P.
P. 2 minus 1 is 1.
Okay.
Okay. So that solves for the determinant of A. Now, moving on to our more difficult sub-question. For what values of P and Q does A and E have an inverse? Right? So kapag ganong klase ng question yung may encounter nyo, right? We just have to identify ano ba yung magva-violate dun sa condition na may inverse CA plus E. Alright? So, let's just say that A plus E, or any matrix for that matter, has an inverse if the determinant of A plus E is not equal to 0. Okay? That's a general rule. And you'll find it very useful later on when you try to solve, of course you already tried doing it, if you try to solve system of linear equations, right? Or if you try to find the solution of homogeneous matrices. No? So in this case, if A and E has an inverse only if and only if its determinant is non-zero, then let's find the values of P and Q that will make the determinant of A plus E equal to 0. So yun ngayon yung iwasan mo. So P and Q P and Q can take on any value other than those that will make A plus E, or that will make the determinant of A plus E equal to 0, right? So ano ba muna si A plus E? Okay, so A plus E is equal to, you can do this mechanically. So you can just add these two together. So you have Q plus 1. So this would be Q plus 1 Right? Addition of matrices lang to. So you have q plus 1. So q plus 1, negative 1 plus 1, this becomes 0. Okay? Q minus 2 plus 1, that's just q minus 1. Tama? Okay. So 1 plus 1, right? Second row, first column plus second row, first column. So 1 plus 1, that's 2. Okay. Next, we have negative p plus 1. So that's 1 minus p. Okay. And then you have 2 minus p plus 1. So that's going to be 3 minus p. Now for the third row, you have 2 plus 1 equals 3. You have negative 1 plus 1, that's 0. And 0 plus 1, 1. Okay. So you wanted to find, okay, P and Q such that the determinant of A plus E will be 0. And therefore, any other values, any other values of any other values of P and Q will be, or will ensure that A and E, or A plus E, has an inverse. Have an inverse. So kumbaga elimination method of identifying which values of P and Q should we eliminate in order to ensure that A plus E has an inverse. So let's get the determinant of A plus E then. Right? So the determinant, and let me copy the matrix. Okay. The determinant of A plus E is equal to, let's use the third row again. No? Or ano ba, mas okay ba si first row if I delete this? Yeah, maybe we can use the first row. Or no, let's just use the third row. So let's use the third row. So that's 3. Okay. C dot 3 times the determinant of the resulting matrix obtained by deleting the third row and first column. So that's gonna be 0, q minus 1, 1 minus p, and then 3 minus p. You have a 0, so it doesn't really matter now. And let's move on to the third element. So that's just gonna be the determinant of the 2 by 2 matrix obtained by deleting the third row and the third column. So you have q plus 1, 0, 2, 1 minus p. So I delete this row and this column. Okay. So solving for the determinant. So by the end of the course, you should be able to solve for the determinants of the 2 by 2 matrix fairly quickly, no? Kasi essential naman siya even in other courses. So this becomes 3 times 0 times 3 minus p, it's 0, minus 1 minus p, and q minus 1. Okay? As simple as that. Diagonal minus the off diagonal. Okay? Diagonal minus the off diagonal. And then finally, we'll have the determinant of this second submatrix. So it's going to be the diagonal. So q plus 1 times 1 minus p times the off diagonal, which is 0. So we'll leave it as it is. Okay. Now, okay, so I can factor some terms, no? Okay, so I can factor 1 minus p Yeah, I can factor 1 minus p and set this determinant equal to 0. Alright, so this is going to be equal to 1 minus p, okay, times, ipasok na natin si 3 dito. So this becomes negative 3 q minus 1 plus q, sorry, q plus 1. Oops, sorry about that. So that's negative 3 q minus 1 plus q plus 1. Okay. And set it equal to 0. Okay. So let me copy this entire line here. Oops. Copy this entire line here. Bakit ba natin, again, let me just reiterate why are we setting this equal to 0. It's because we wanted to find which values of P and Q should we avoid, right? We want to find the values of P and Q that we should avoid. If you wanted to let A plus E have an inverse, okay? So solving this, right? So since this is this is a factor, these two bracketed terms are factors, we can just say that, all right, either 1 minus P is equal to 0 or the second term, yung itong bracketed term na to, we can add this together in the process. So this bracketed term, or this is equivalent to negative 3q plus q. So this is negative 2q. Yeah. Am I doing this correctly? Let me just double check now. Let's double check if we're doing this properly. Okay. So 3, negative 1, okay. 0 minus 1. Okay, this is negative, that's correct. This 3, 3, so q plus 1, right? Q plus 1, 1 minus p times 2 times 0, 0. Okay, so this, okay. Q plus 1 and q minus 1. Okay. Okay. 2, 1 minus p, 3 minus p. Okay, okay. So we can simplify this, and this is essentially equal to negative 3q plus q, so negative 2q. Okay. And then you have positive 3 here, so negative 3 times negative 1, that's positive 3 plus 1, and that's equal to 4. Okay. And that's basically equal to 0 as well. Kasi nga factor naman to eh. No? So if either one of them is equal to 0, then we can easily solve for P and Q. Okay. Therefore, P is equal to 1 and Q is equal to what? Negative 4 divided by negative 2 equal to 2. Correct. So ano yung sabihin nitong numbers na to? So these numbers indicate that at P is equal to 1 or Q is equal to 2, A plus E doesn't have an inverse. Therefore, A plus E has an inverse
when P is not
when
equal to
P is not equal to 1, correct? P is not equal to 1, or actually, yung inverse ito eh, and Q is not equal to, that's correct, Q is not equal to 2. Okay? So yun yung solution sa number, that's number 10. No? That's number 10.
Sir?
Yep.
Excuse me po. Sir, dun po sa kanina po, Sa 10A po, yung pagkuha po ng determinant ng A. Sir, hindi po ba ang sagot is Q minus 2 times P plus 1?
Okay, let's check, no? So Q minus 2, 2P, 2 minus 1. Yeah, sorry. Yeah. Correct. So that's, thank you for that. So that's P plus, that's P plus 1. Okay, 2P minus P, that's P. 2 minus 1 is 1. Yeah, thank you so much for that.
Sige po.
Okay, so that solves, no? That solves number 10. Now, how about number 11? Right? Kapag ganito, pag nakita kayo ng, sorry, let me just check. Yung determinant of A, yung diagonal, that's only applicable, if I recall correctly, that's only applicable if you have a diagonal matrix. So diagonal matrix meaning if you have non-zero diagonal elements and zero off diagonal elements. So basically, it's like having a matrix, no? It's like having a matrix whose diagonals are non-zero, tapos yung lahat ng off diagonals mo would be 0. Or actually, kung triangular, let me double check, no, my references. If it's a diagonal, if it's a triangular matrix, sorry, let me just, but that's an interesting question kasi it could be used, you can use that as a shortcut. Yeah, I think it's only applicable when your matrix is triangular. Your matrix is triangular, meaning yung nasa lower triangular mo, it's either yung nasa lower triangular or upper triangular na matrix mo is 0. Ano yung sabihin nun? If say for instance you have this matrix, right? You have this matrix, okay? And suppose these are zeros, 0, 0. Tapos ito, non-zero lahat to. And, sorry, lagyan natin ng A12, sorry, A12, A13. Yeah, that's a very good point that you raised, no? So this is A22, A23, A33. So for a triangular matrix, the determinant would just be the product. Ito lang. It's just the product of the diagonal entries. You can verify that yourself. Either nandito yung 0 sa lower triangular or nasa upper triangular. Or pwedeng parehong 0 siya or diagonal matrix siya. So the point is, if your matrix is triangular, right, the determinant will just be the product of the diagonal. Right. So thank you for raising that. That's actually a nice shortcut. Yep.
May ginagawa po kasi kami before na ipakopy namin yung first 2 rows tapos magda-diagonal method. Pero hindi ko po kasi siya na-try sa number 10. Possible po ba if same yung answer, i-submit ko siya ng ganun?
Yeah. Oh, I think you're referring to the Sarus method ba yun? You're basically copying the first 2 columns. No? You copy the first 2 columns here, tapos iba-basket weave mo siya. Another term for the Sarus method is the basket weave, right? Although personally, ano ibang term ba?
Hindi, butterfly lang po yung tawag ko kasi.
Yeah, okay. But yeah, personally speaking, mas confusing sa akin si Sarus method. And yeah, Sarus method is only applicable for 3x3 matrices. Hindi siya pwede sa any higher order, no. 2 by 2 kasi simple lang naman si 2 by 2 eh. But for higher order matrices, or sorry, matrices with higher dimensions, hindi siya applicable. Okay, so let's move on to number 11. Right, so bilisan na lang natin kasi well, it's already 9 o'clock. And maybe what I'll do next meeting, sige, sabay-sabay na lang natin. Alright, so let A, B, C, X, Y be n by n matrices. No? So let me just write the given here. Okay, suppose you have AX plus Y equals B. Okay. All of them are matrices. These are not variables. These are matrices. Okay, so you have X plus 2. 2 is a scalar, of course. 2A inverse Y equals C. Now the question is, you wanted to express X and Y in terms of A, B, and C. So how do we do that? So we can start off by looking at the second equation and see that X, we can actually extract X here. So X will be equal to C minus 2A inverse Y, correct? Now, since I already have X, right, I'll just plug this back in the first equation. Okay. So if I plug this back in the first equation, I'll get A C minus 2A inverse Y plus Y, right, equals B. Okay. Now, I can distribute A across, distribute A across C and 2A inverse Y, and I will get AC minus 2, right? Since this is a scalar, you can just factor this out. So you'll just end up with A times A inverse Y plus Y equals B. Okay? Oh yeah, that's very good. No? So depende sa inyo kung saan kayo mas comfortable, kung basket weave or cofactor method. I just think that when you use the cofactor method, it's easier to double check if you have some issues. Or kung gusto niyo ng mas madali, and if you're familiar with statistical software, you can use the statistical software to solve for the determinant of a matrix, pang double check. Yun lang. So, or kung marunong kayo mag-MATLAB, pwede din naman siguro. Right. But of course, you're still, in order for you to learn, right, in order for you to have a better grasp of the operations, you may want to do it manually. Right, so going back to our problem. So this cancels out, right? Because A times A inverse, that's the identity. So you're left with AC minus 2Y plus Y equals B, right? And since this is a scalar operation, so this is just a scalar, this converts to, let me just move this here. This is equal to AC minus Y equals B. And therefore, Y
Equal to AC minus B.
is equal to AC minus B. That's correct. Now, I'm going to plug this back in our expression for X. So what's the expression for X? So that's X equals C minus 2A inverse Y. Okay. So I'm just going to plug this. I'm just going to plug Y. And therefore, you have X equals C minus 2A inverse times AC minus B. Okay. And distributing terms, you'll have X equals C minus 2A inverse AC minus B. Okay. A inverse A cancels out, right? Becomes an identity matrix. And therefore, X is equal to C minus 2C minus B, or negative C minus B. Sorry, you still have, sorry. You still have 2A, no? You still have to distribute this across kasi nga A, B, and C yan. Okay. So
2A,
you have
2A
plus
inverse.
2A inverse B, correct. 2A inverse B. Okay. So in other words, you have negative C plus 2A inverse B. So there you go. You have an expression. You have an expression of x and y in terms of A, B, and C. Okay. So questions? Okay. So let's move on to the last problem, number 13 kasi ano na, it's already 9:07. So let's solve the system of linear equations. So here's the thing, no, and I want you to acquire this practice later on when you take up your advanced courses. When you see a system of linear equations like this one, I want you to get used. I want you to get used to moving all of the endogenous terms on the left-hand side and leaving all of the exogenous variables on the right-hand side. Right? It will be very useful, especially in macroeconomics. Right? Kung familiar kayo sa ISLM equations, right? You'll have to get used to solving, or you'll have to get used to arranging equations, right? Na mas madali mo siyang mako-convert. You can easily convert it into its matrix form, right? So like this one, I can just move all of the right-hand side terms on the left-hand side. So I will get what? 5 minus
5
lambda.
minus lambda x.
That's correct. X plus 2y plus z equals 0. Okay. You have 2x plus 1 minus lambda y equals 0. And then you have x plus 1 minus lambda z equals 0. If you have viewed the tutorial video on eigenvalues, this is basically that. You're trying to solve for the eigenvalues. You're trying to solve for the values of lambda that will make the determinant of the resulting matrix, as you will see here, equal to 0. Okay, so this is 5 minus lambda. Right? This is 2, this is 1, this is 2, sorry, this is 2, this is 1 minus lambda. This is 0. Ba't siya naging 0? Kasi walang z sa second equation. Right? So you have 1, walang 0, walang y sa third equation. So this becomes 0, and this becomes 1 minus lambda. Okay. This equal to the vector of unknowns. You have your vector of unknowns here. You have x, y, and z. And then you have your 0 vector. Your 0 vector here. So according to the tutorial video, eigenvalues are basically, or this matrix is called the characteristic matrix of A. No? Or solving for solving for lambda requires that the determinant of this matrix is 0. Okay? So if this matrix is 0, then this vector is basically the eigenvector of A without the lambda. Okay. So what's the determinant of, let's denote this as matrix B. What's the determinant of B? Right, let's denote this as matrix B. So the determinant of matrix B, so let's use the third row kasi ito yung may 0. Pwede rin naman si second row, you'll get the same results anyway. So let's get the determinant of matrix B. So that's gonna be, this is 1 times the determinant of the submatrix obtained by deleting the first the third row and the first column. So it's going to be 2, 1, 1 minus lambda, and 0. Okay. The second term doesn't matter, so we'll just leave it that. So you have 1 minus lambda. Right? You have 1 minus lambda, and you have the determinant of this submatrix, which is obtained by deleting the third row and the third column. So you have 5 minus lambda, right? You have 2, and you have 1 minus lambda. And set it equal to 0. Kasi nga yun yung gusto natin mangyari. What are the values? What are the values of lambda such that this system of equations has non-trivial solutions? So let me just write it here, and for the reference of the other members of the class, no? For a homogeneous system like this one, if the determinant of, or if B, if matrix B is singular, this implies that the determinant of B is 0. And this implies that you have non-trivial solutions, meaning non-zero yung laman nitong x, y, and z na to. However, if B is non-singular, it means that the determinant of B is not equal to 0. Determinant of B is not equal to 0. And this implies that you have what we call the trivial solution. But siya tinawag na trivial solution? It's basically mathematics telling you that if the determinant of a matrix is non-zero, then for obvious reasons, since the right-hand side is 0, kung ito non-singular, right? If this is non-singular and the right-hand side is just equal to 0, right? Then if I take the inverse, if I multiply both sides by the inverse of B, right? Ano mangyayari dito? If I multiply the inverse of B by 0, ano mangyayari? What do I get? 0 pa rin, di ba? I'd still get a 0. Kasi multiply a matrix with 0, I get a 0 matrix. So therefore, the solution for x, y, and z would be 0, and that's trivial. Okay? So in this exercise, what we're trying to solve is the value for lambda at which we'll get a non-trivial solution. Right? Or we will get non-zero values for x, y, and z. Okay, so moving on with the computation. So you have the determinant of this matrix. So you have 0, right? 0 minus 1 minus lambda. So that's just 1 minus lambda. Okay. Plus, okay, 1 minus lambda times the determinant of this submatrix. So this is 5 minus lambda times 1 minus lambda minus 4. Okay. And that's equal to, we set it equal to 0. Okay. Now, to simplify the operation, maybe we can factor out 1 minus lambda already. No? So let's try to factor 1 minus lambda out of this, out of this expression. So we'll have 1 minus lambda. Yung unang 1 minus lambda lang muna. Okay. And then you have negative 1 plus 5 minus lambda. Pwede naman to. So 1 minus lambda minus 4. Okay. Okay. And set it equal to 0. Again, since you have two factors here, you have two factors, no? you can already set one of the lambda values to 0. So, or one of the binomials to 0. Sorry, one of the expressions to 0. So let me copy this. Okay. So if this is 0, if this product is 0, and then if it implies that 1 minus lambda must be equal to 0. Okay. 1 minus lambda must be equal to 0. And therefore, lambda is equal to 1. Okay. Okay. So based on this expression, we can just verify this later. Okay. Just verify this later. Okay. So okay, so let's set it. So let me solve this. No, let me solve for the bracketed term, okay. And let me just verify this later. No? So let's have -1 plus 5 minus lambda 1 minus lambda, okay, minus 4. Okay. Set it equal to 0. Okay. So let me multiply. So basically, let me add this. So we'll have -5. Okay. Have -5 plus let's multiply this binomial. So you have 5 plus 5 minus 6 lambda plus lambda squared. Okay, set it equal to 0. Right? So 5 cancels out, so you're left with this expression. So you're left with lambda squared minus 6 lambda equals 0. Therefore, lambda
1, 0, and 6.
Yeah, you have lambda times lambda minus 6 equals 0. So you end up with 3 possible values. No? You end up with 3 possible values of lambda, right? And therefore, the eigenvalues, right? Of course, that's already an advanced lesson, but the values of lambda that will ensure that you have non-trivial solutions will be 1, 0,
6, and 0.
6. Okay. So let me just verify this a little closely, and maybe we can review this again in the next tutorial. Okay. So yeah, I'm sorry. It's already 9:20, and we can just continue this tutorial in next week. So please expect to receive the next lecture exercise by Friday. I'm almost done with it kasi wala nang masyadong material for eigenvalues, no? Kasi I would presume it's an advanced topic already. So are there any other questions or concerns? So let me just stop the recording na. And I'll